The title of this video is Naming Ionic Compounds. In this video, we will touch on the importance of systematic names, then learn how to determine the name of an ionic compound from a chemical formula. Nomenclature is the term used for the systematic way of naming compounds and molecules. It is important so that scientists from all over the world can share information with each other in an accurate and efficient manner. Before we discuss how to name ionic compounds, let's review some relevant vocabulary. First, an ionic bond involves charged species known as ions. The positively charged ion is called the cation, while the negatively charged ion is called the anion. Ions consisting of only one atom are called monoatomic. Those containing multiple atoms are called polyatomic. Finally, a column on the periodic table is called a group. Groups are numbered from left to right. Another important term is oxidation state. When discussing ions, the oxidation state is the ionic charge. The group 1 alkaline metals will have an oxidation state of +1, and the group 2 alkaline earth metals have an oxidation state of +2. The transition metals, sometimes known as d-block metals, because of their partially filled d orbitals, have multiple possible oxidation states. When writing the name of compounds with these metals, it is necessary to specify the oxidation state with a Roman numeral. This slide shows the atomic symbols of the transition metals and lists their possible oxidation states. This slide shows a table of polyatomic anions with their formula and ionic charge. There are two parts to the chemical name of an ionic compound. First, you name the cation, which is usually a metal. Then you name the anion, which is usually a nonmetal. If more than one oxidation state for the cation is possible, include the oxidation state as a Roman numeral in parentheses following the name of the cation. The anion may be either monoatomic or polyatomic. If it is monoatomic, change the end of the word to "ide". If it is polyatomic, simply state the name of the ion. Now we will take a look at several examples. First, we look at CaF2. The cation is monoatomic calcium, which always has an oxidation state of +2. The anion is monoatomic fluorine, with an oxidation state of -1. The name of this compound is calcium fluoride. Notice how the ending of fluorine was changed to fluoride. The next example is NH4OH. Here the cation is polyatomic ammonium with an oxidation state of +1. The anion is polyatomic hydroxide with oxidation state -1. The chemical name for the compound is ammonium hydroxide. Now let's look at HgCN2. The cation is monoatomic mercury. Since mercury is a d-block element, it has more than one possible oxidation state. In order to figure out what the oxidation state is, we need to examine the anion. The anion is cyanide. Each cyanide contributes a -1 charge. Since there are two cyanides, the total negative charge is -1 times 2 equals -2. The total positive charge of mercury must neutralize the total negative charge of cyanide. That means the one mercury must have an oxidation state of +2. To indicate this, we write the name as mercury 2 cyanide, with Roman numeral 2 in parentheses. The last example is Cu3BO32. Again, we are not sure of the oxidation state of copper because it is a d-block element, so we need to examine the anion. This time, our anion is borate with a charge of -3. Since there are two borates, the total negative charge is -3 times 2 equals -6. To solve for the oxidation state of copper, we set the total positive charge equal to the oxidation state of copper times the number of copper atoms. When we solve this equation, we find that copper has an oxidation state of +2. Therefore, the name of this compound is copper 2 borate. Now, take some time to see if you can come up with the names of these compounds.